Hey, so moving on, question 5. Express 4 theta minus sine theta in this form where r is positive and theta is acute. Okay. So let's just start with part I, shall we? So the key to this is to start with the expression here. R cos theta plus alpha. Okay. And we can expand this using some of our trigonometric rules. So we can write this as r cos theta cos alpha minus r sine theta sine alpha. Now what we can do is we can compare coefficients. Okay, so in our question we had cos theta, but now we've got r cos theta cos alpha. So that just means that we have r cos alpha equals 4. And similarly, comparing coefficients with sine theta, we have r sine alpha equals 1. Cool. We could rewrite these as r cos alpha equals 4 over r and sine alpha equals 1 over r, but I'm not going to do that yet. What I'm instead going to do is I'm going to do this equation divided by this equation. Okay. So that is going to be, if I do r sine alpha on the left hand side divided by r cos alpha, well, sine over cos is just tan alpha. And on the right hand side I've got 1 divided by 4, so that's 1 over 4. Okay. So what I can do is draw a right angled triangle. Okay. Let's call this alpha. Okay. Tan alpha, well, we know SOHCAHTOA. Tan alpha, so that's opposite over adjacent, that's 1 over 4. If we remember, I said that we could say that cos alpha was 4 over r, so that would be adjacent over hypotenuse, so the hypotenuse is just r. Okay. To find r then, we can use Pythagoras. R squared equals 1 squared plus 4 squared, which equals 17. So r equals root 17. Okay. So r is positive, perfect, solved. Next, let's look at alpha. So we know that tan alpha equals 1 over 4. So that means that alpha equals inverse tan 1 over 4. We could do that in our calculator and we would get 14 degrees to 3 significant figures. Okay. Perfect. So that's part 1 done. So let's look at part 2 then. Okay. So let's write the equation it gives us. So 4 cos theta minus sine theta equals 2. Okay. Now we're going to use what we did in the part 1 for part 2. So in part 1 we rewrote this in the form r cos theta plus alpha. Okay, so we can say that's equal to 2 from part 1. Okay, we can replace r and alpha. So we can say it's root 17. I'm going to leave alpha as it is because I've done some rounding here and I'd rather not round in my equations. Okay, so that just means that cos theta plus alpha equals 2 over root 17. So that means that theta plus alpha equals the arc sine or inverse cos of 2 over root 17. Okay, so now this is where we have to look at the question. And in the question it says that we want all the values of theta between 180 degrees and minus 180 degrees. So I'm just going to make this all a little bit smaller. Maybe not. Okay, so we can look at a graph for cos theta. So I'm just going to draw that here. Okay, cos theta, so that starts at 1, comes down, goes to 0, and back up again. And similarly in the negative x direction. Okay, that's pi, and that's minus pi. Okay, and we're looking for solutions between here and here. Okay, so 2 root 17, that's about 0.5, so just a bit less than 0.5, so somewhere around here. So we've got solutions there, there, and there. Okay, cool. And then, so theta plus alpha is going to be any one of these 4 solutions. So, and then we're going to take off 14 degrees. When we take off 14 degrees from this value, it's going to be bigger than 180, so we can ignore this solution. Similarly, when we take off 14 degrees from this solution here, we're going to get something that's more negative, so we can ignore that solution. So the only 2 solutions we're interested in are this positive solution and the negative solution here. Okay. When we plug that into our calculator, we get theta plus alpha equal to so inverse cos of 2 over root 17. Lovely. That gives us 61 degrees to 3SF, or minus the same thing. Because we've got these 2 solutions. Okay. So that means that theta, that's going to equal 61 minus 14 degrees, because alpha was 14. So 47 degrees, or minus 75 degrees. Perfect. Question solved.